Hi everyone, today we will learn about subtopic 3.3 differentiation of trigonometry function. Subtopic 3.3 differentiation of trigonometric function course framework A. Differentiate the basic trigonometric function. The first one is fx is equal to sin x, then f prime x equal cos x. The second one is if fx equal cos x, then f prime x equal negative sin x. And then the last one is if fx equal tangent x, then f prime x is equal to the secant square x. Differentiate the basic trigonometric function. A d dx sin x equal cos x. B d dx cos x equal negative sin x. C d dx tangent x equal secant square x. D d dx cot x equal negative cosec square x. And then E d dx secant x equal secant x tangent x. Then the last one is d dx cosec x equal negative cosec x cot x. However, for this semester, we only learn about A, B, and C only. Notes: differentiation of the above formula are only true for angles which are measured in radians. Differentiation of trigonometric function using neighbor concept. Okay, the first one we look at for the left hand side, then we look at also for the right hand side. Now we put for the left hand side is positive sign, and then for the right hand side we put negative sign. If you look at for the left hand side, we have sin x, tangent x, and secant x. If you look at for the right hand side, we have cos x, cos x, and cosec x. And then if we look at also sin x is a neighbor of cos x, and then for the tangent x, the neighbor is of secant x, and then for the cot x, the neighbor is of cosec x. Now if we differentiate for the left hand side, for the sin x d dx sin x, we get cos x. And then if we differentiate tangent x, we have secant square x. And now if we differentiate secant x, we get tangent x secant x. And also for the if we differentiate for the right hand side, we get d dx cos x equal to the negative sin x. And also if we differentiate d dx cot x, we get negative cosec square x. Next, if we differentiate cosec x, we get negative cosec x cos x. However, we will learn only sin x, tangent x, and then cos x. Example 1. Differentiate the following with respect to x. A. 3 sin x minus 4 cos x. B. 3 tangent x minus x to the power of 4 plus 5 pi. Then the solution is d dx 3 sin x minus 4 cos x. If we differentiate sin, we get cos x. And then if we differentiate cos x, we get negative sin x. 3 and 4 is a constant. Then if we simplify, we can have that 3 cos x plus 4 sin x. Now we look at for the example 1b, 3 tangent x minus x to the power of 4 plus 5 pi. Differentiate this. If we differentiate tangent x, we get secant square x. And then if we differentiate negative x to the power of 4, we have 4x cubed. And then 5 pi is a constant. Differentiate constant, we get 0. Example 1c. Differentiate the following with respect to x. Y equal to 4 cos x plus 5 tangent x. Then t y equal to the 6 cos x minus 3 over x minus e to the power of 2. The first one we look at for the example 1c, y equal to the 4 cos x plus 5 tangent x. Differentiate cos, we get negative sin x, and then differentiate tangent, we get secant squared x. 4 and 5 is a constant, then we simplify, we get 5 secant squared x minus 4 sin x. Now, if you look at for the example 1d, first we simplify. Y equal to the 6 cos x, simplify 3 over x, we get 3x to the power of negative 1 minus e to the power of 2. Now, we differentiate dy dx, differentiate cos, we get negative sign, then differentiate 3x to the power of negative 1, we get 3 over x squared. Now differentiate e to the power of 2, we get 0. We simplify until we have 3 over x squared minus 6 sin x. Example 2. Differentiate the following with respect to x. A, y equal to the sin x. Now, if we differentiate sin, we get cos 6x. The angle doesn't change. Now, we differentiate again the angle 6x. We have 6 cos 6x. Then, for the example B, y equal to the cos x cubed. Differentiate cos, we get negative sign. But x cubed here is angle, then angle doesn't change. Now we differentiate angle, we have 3x squared, then we put in the front here, so we can have that negative 3x squared sine x cubed. Example 2. Differentiate the following with respect to x. Y equal to cos 5x plus 4. Dy equal to the tangent pi over 6 minus 3x. If you look at for this example, the angle is 5x plus 4, and then the angle is pi over 6 minus 3x. The first one, we differentiate trigo, then next we differentiate the angle. C. Y equal to the cos 5x plus 4. Differentiate cos, we get negative sign. Then we just copy for the angle. Now we differentiate the angle 5x plus 4. We get 5. Then the answer is negative 5 sine 5x plus 4. Look at for the example 2D. Y equal to the tangent pi over 6 minus 3x. Again, if we differentiate tangent, we get secant squared x. Then the angle doesn't change. We just copy. Then we have pi over 6 minus 3x. Next, we differentiate angle. We get negative 3. Differentiate pi over 6 is constant. So we get 0. Then we have the answer is negative 3 secant squared pi over 6 minus 3x. Differentiation of trigonometric function. If we have function fx, d dx sine to the power of n fx. Fx is angle. And then if we differentiate, we have n sine to the power of n minus 1 fx d dx sine fx. Same for the cos to the power of n fx is equal to the n cos to the power of n minus 1 fx d dx cos fx. And then the last one is d dx tangent to the power of n fx equal to the n tangent n minus 1 fx dx tangent fx. Remember that we have 3 steps to differentiate the trigonometric function. The first one is differentiate using power rule. The second one is differentiate trigonometric function. Then the last step is differentiate fx. fx is an angle of trigonometric function. Example 3. Differentiate the following with respect to x. A. Y equal to the sine x in bracket to the power of 4. B. Fx equal to the tangent to the power of 3, 5x. Now we let u is equal to the sine x. We differentiate u with respect to x, so we get cos x. Next, if we differentiate y is equal to the u to the power of 4 by using power rule, so we have dy du, we have 4u to the power of 3. Now we will use chain rule formula. Dy dx is equal to the dy du times du dx. Next, we replace that. Dy du is equal to the 4u to the power of 3, and then du dx is equal to the cos x. Next, we replace that. U is equal to the sine x, and then replace that. Du dx is cos x. Now we simplify, we can get 4 cos x sine to the power of 3x. Example 3b. Fx is equal to tangent to the power of 3, 5x. Okay, first we rearrange this equation. Tangent to the power of 3, 5x become tangent 5x in bracket to the power of 3. Next, we follow 3 steps here. The first one, we differentiate using power rule. Power here is 3. Then, using power rule, we have that f prime x is equal to the 3 tangent 5x power of 2. Power is reduced by 1. Next, we differentiate trigo. Trigo here is tangent. Differentiate tangent, we get secant squared x. The angle doesn't change, 5x. Now we differentiate fx. Fx here is 5x. Differentiate 5x, we get 5 here. Then we simplify, we can get 15 tangent to the power of 2, 5x secant squared 5x. Example 4. Find the derivative of the following. Y equal to the tangent x sin x, and b, y equal to the cos x over sin x. How to solve for this question? Y equal to the tangent x sin x. We have two functions here, tangent x and sin x. Actually, we will use the product rule formula. Now, if we take tangent x and then we differentiate sin x, if we take sin x, we will differentiate tangent x. By using product rule formula, we have d dx uv prime plus vu prime. Next, we let that u is equal to the tangent x, differentiate tangent x, we get secant squared x. If we let v is equal to the sin x, we have v prime is equal to the cos x. Now we cross here. Therefore, we can have that uv prime plus vu prime. That is tangent x cos x plus sin x secant squared x. If we simplify, we can get the answer is sin x 1 plus secant squared x. The last example, y equal to the cos x over sin x. For this question, we will use quotient rule formula. So dy dx is equal to the sin x differentiate cos x minus cos x differentiate sin x over sin x squared, or we will use this alternative, d dx u over v. Now v squared to the bottom, and then vu prime always minus here uv prime. Then we let that u is equal to the cos x. Then differentiate u, we get negative sin x. Then we let that v is equal to the sin x. Differentiate sin, we get cos x. Then again we cross multiply here vu minus this one until we get sin x minus cos x over sin squared x, and then we get negative sin squared x minus cos squared x. Then factorize negative sin squared x plus cos squared x. Here, by using identity trigo, sin squared x plus cos squared x becomes 1 here. We simplify, then we get negative 1 over sin squared x. Then we have negative cosec squared x. Okay, some exercises here. Try all of these exercises A, B, C, D, E, and F. Be right back. Continue to the subtopic 3.4.